So we're going to take a look at how to solve quadratic word problems when the equation is given to you in factored form. The question is that Ryan buys 210 feet of fencing to section off part of his land for a vegetable garden. The garden's area in square feet as a function of the garden's width, W in feet, is modeled by G of W equals W times quantity 105 minus W. And we're going to take a look at question A, which is what is the maximum area possible? Okay. All right. So you want to know what W stands for and you want to know what Y stands for and write that down. You can pause the video if you want to try that out while I set this up for you guys so you can see the work. All right. So this was the equation of the problem and the question is maximum area. The first thing I'm going to do is note what W and Y stand for. So W was the width in feet, so I'm going to write that down because that's a good thing to do, especially if the words are unfamiliar. In this case, it might not be, but it's a good practice, especially if you see a bunch of science words. All right, the Y value, or G of W, is going to be the area. And I know that because the word problem said the garden's area as a function. So whenever you see in the word problem the garden's area as a function, so whatever the function represents, which is garden area, that's what Y is equal to. So the first thing we did was we labeled these. They're asking for the maximum area. So as soon as you see the word maximum, you know they're asking for a vertex question, hopefully. If not, this is a good review. So when you see maximum, it's a vertex question. So we're looking for the vertex of this problem, okay? So because it's factored, you have two options. One is you can solve for the x-intercepts, and then the vertex is always right in the middle of those 2 points. So I'm going to do it that way. So step one, find the x-intercepts. So because, so the x-intercepts are when the equation equals 0. So W times 105 minus W equals 0. So this is going to equal 0 if W equals 0. And the other factor is 105 minus W equals 0. So this is already solved. This one, you have to subtract 105 from both sides. And then multiply by -1, or divide by -1, excuse me. Either way will work though. And so the other answer is W equals 105. So these are my two x-intercepts, 0, 0, and 105, 0. Step 2, the vertex is always halfway in between these points. So I'm going to take 0 plus 105 and divide by 2, which is going to end up being 52.5. So the vertex is at x value of 52.5 for the vertex. Step 3, they don't want the x value, or the W value, excuse me. I call that W. Because that's the width. They're asking for the maximum area. So I'm going to plug this in for the vertex and find out what the area is at 52.5. So I'm going to go back to the original problem. W is 52.5. Then quantity 105 minus 52.5. I'm going to do this on a calculator. So it's going to be that's going to end up being 2,756.25 square feet. That will be the maximum. And that's going to be it if it's already in factored form.